Hey everybody, this is Larry. This is me going with Q4 of the biweekly contest 54, minimum cost to change the final value of expression. So this was a really hard problem. I have solved this before, which is how I am able to solve it. And even then, I actually solved another version of this, or at least an incorrect version of this, that I had to spend some time kind of changing it into it. But the core thing to notice for this problem, and the first thing that you should do is to hit the like button, hit the subscribe button, join me on Discord where we talk about contest problems right after the contest. So if you're into doing contests, join, because the more the merrier, because I like chatting about these things as, as a nerd would. But yeah, so yeah, for this problem, the key thing to note is that every step of the way, there are only two solutions, right? You can either get a 1 or a 0. So that's the key thing to notice. And then the second thing is that, and then after that, the other prerequisite for this problem is just is knowing how to solve a problem using infix notation. So that's a prerequisite. I'm not going to get into that part that much. I used the stack implementation. If you look at other top people's solution, they have done it with depth first search, and that's fine as well. And these are things to kind of Google and look up, because it is a little bit tricky, but the idea, and this is a very easy, this is a relatively easy, it's not an easy one, but it's a relatively easy expression, infix expression to parse, which is that, you have these things and then you go from left to right with parentheses. So every time you see a left parentheses, you can match it with the right parentheses, and then solve the answer for everything in the middle. And then after you do all that, you go from left to right on everything as well. The key thing to know again is that there are only two possible solutions for every expression, no matter how complicated, which is a 0 and 1. So the idea here is to keep track of the cost of flipping the answer from 0 to 1. It's kind of like dynamic programming, but it's very in the sense that, you keep track of, okay, what's the minimum cost to go to 1? And what's the minimum cost of going to 0? Or the other way around. And because so you're going to get two answers at the end. One is just your original answer, like whatever this thing would have evaluate to anyway. And then the other answer is the cost that it would take. I did this in a funky way because I was hacking a solution that I had, which was a little bit off. So I don't know that I would do it this way if I had to do it live again. But let's go over the code, right? I did it again with a stack. You can do this with recursion, so an implicit stack as well, which is what I see a lot of people did, and probably I should have done, because going from left to right, I had some issues there. But that said, it's a let's go through it, right? So now this is already if this looks confusing to you, like I said, you have to practice infix notation parsing. So that part, there's a lot of understanding and literature about it, so I'm not going to get into it that much. But yeah, for each character in the expression, this is the meat part. So we're going to skip for a quick second. But if it's a 0 or 1, we put it into the array. We put it on the stack. And what does this mean, right? Like I said, so the stack will contain two things, which I haven't talked about yet, so not like I said. But one is the cost of going to 0 and the cost of changing to 1. So if the number we see is 0, then it costs 0 to go to 0, and it costs 1 to change it to 1. Now, conversely or inversely, if the thing that we're parsing is a 1, then it costs one operation to change it to 0, and 0 operation to change it to 1, right? So these are our base case, if you want to call it that. And if it's a left paren, then I so I added this in a little bit later. It looks a little bit funky, I know, but yeah. But otherwise, we put the either the operator, which is an and or an or. That's a really weird statement. Basically, the two operators that the bitwise operators that we have, we append it, or we append the left parentheses. We append the left parentheses. Wow, that's a mouthful. Anyway, so then this is the meat of the problem, right? Which is the right. What happens when we process it right? So the thing that I do is that, okay, so I have a thing to process. So until we see the left paren, I push everything into the thing that we have to process now. And then we pop, because this pop is just to get rid of the left parens at the very end. So, okay. So basically, we're going from left to right. And again, because I'm copying code from a previous thing, so this is a little bit awkward because the original one, they're all binary, like all the operations are binary instead of this like chain kind of thing. So it's a little bit awkward. So I do it backwards with respect of popping. But if I go from left to right, this would have been the way to go, pretty much. Yeah. Because here, like I inverted this one intentionally so that I could invert it again. Because like I said, this is just me doing it the original way. So that's a little bit awkward. Yeah. Anyway, and I have my video of me, quote unquote, solving it during the contest. I did solve this one during a previous contest. So it's not like I'm cheating by copying someone else's code. I'm copying my own code. So, you know, with my comments, as you can see. But yeah. So now, as we see, now we have a binary operation, right? We have the operation that's in the middle, which is the op, and then we have the number of edits to get to 0 on the A side, and then on the this is on the B side. Whoops. Yeah. So now you have some operation, you know, A or B, and yeah, and this is basically is self-explanatory with respect to I have comments. So this is just, as we said before in the stack, the number of edits to get to A to 0, the number of edits to get to 1. One of these should be 0, of course, just by what we talked about by default. But that shouldn't matter in either case. So you have the operation here, and then the same thing for B. And then here we just have the new answer. I don't know why I set it to none. I think it's just so that I don't get confused. But yeah. And then at this point, it just becomes exhaustive. And what do I mean by exhaustive? It means just going through the cost of every possible way of going to the cost. Because there's 3 things that you can change given this thing, right? You can either change A, you can either change B, or you could change the operator. And that's basically what I do here. Is that, yeah. So this is the new number of new number of zeros. So if our new digit is 0, so the minimum way to get to 0 is either going to be, okay, the number of edits to get. Oh yeah, let me step back a second. So this is for the OR operation, right? So everything is OR. So if you have 0 or 0, then you're going to get a 0. So that means that you don't need any operation. So that's basically the way that we go. How do you get a 1? Well, yeah, and this is, I think the comment here talks about it pretty deeply, which is that, okay, we take the cheapest way to get to a 1 by, okay, if we have, the cheapest way to get to the 1 is equal to, if A is 0 and B is 1, so that's the number of costs here. That's the cost of A getting already at 0, B already at 1, or A is equal to 0, B is already at 0. Oh, sorry, A is equal to 0. A and B are both 1s, so A or B is equal to 1, so that's just the cost there, or this thing, right? So these are our base cases, if you will, because that requires no edits. That's just taking the minimum path. And then here, these are the paths with edits. So, yeah. This is a lot of things to say. So, but this is just going through all the possible cases. literally. So I don't do anything fancy here. You can maybe add some for loops to make this easier, but this is how I did it. So yeah, so now the number of zeros is equal to, well, what we had previously here, or yeah, if A is 0, B is 1, then to get 0, you have to change B of 0. You have to change B to 0. So the cost of that is going to be equal to B0, right? Oh, sorry, I'm saying it all incorrectly. So the cost of that is equal to B1 because, yeah, because that's the cost. So you have to change all the things there to get to 1, right? Because if you have to change every number on the B side, this is going to be the cost. Conversely, yeah, if A is 1 and B is 0, then it costs A of 0 to change it to 0. That's basically the idea. I don't know if that I'm going through the explanation really correctly, but hopefully it makes sense. But basically, we're just going for every possibility. Like I said, I'm going for it really through in this video. But yeah, and then if we want the answer to be a 1, then either it is already a 1 that we get from here, or if they're previously zeros, so if A, then we have to change either B to a 1 or A to a 1. So that's the cost, because that's literally how we define it, right? That's the minimum cost to change it to that digit in that place. Yeah. And of course, lastly, we can also change the sign. We can get the 0 if we change the OR to an N. And it will cost 1 to change the operation, right? So that's just, you know, yeah, I think this is obviously, I kept this part for symmetry reasons, but yeah, if you have, if you want to change to an OR to an N, then what happens? Well, if they're both 0, then 0 and 0 is still 0. 0 and 1 is equal to 0, and 0 and yeah, and 1 and 0 is equal to 0. This is just bitwise things. And then if you change it to an OR, oh sorry, yeah, if you change this to an N, then that would be your cost of doing 0. And of course you take the min. Otherwise, this is the same, which is that, yeah, this will never be true, because this is by definition, here. So this is always going to be bigger. But as I mentioned in the comment, I'm here for symmetry, because I do something similar on the, because on the N side, you do something similar. That's basically it. But yeah, I'm not going to go over these logic here, but that's for the N side. But yeah, so basically, it is dynamic programming in the way that you just take the minimum of all the possibilities on the transitions. So that's basically the idea. I hope that I explained it okay. But yeah. And because, you know, because we keep track of, and at the very end, we processed it and we put the number of, so now this is the number, the minimum number of changes or operations or changes, edits to get to 0. And this is the number of edits to get to 1. And then we add that to the process. We push it back into the stack, and then we keep on processing while we have processed. And then after all the process is done, we should have 1 element left, and then we put it back on the stack, and then we loop again on a kind of like a recursive kind of way. That's all I have. Let me know what you think. It's very long. It's very hard, but I think the core ideas I explain, even if the code is a little bit yucky and maybe confusing. I hope that makes sense. So to go over again, the core ideas is that notice that every step of the way, you keep track of the minimum number of edits to get to 0 and 1, and then just kind of do the infix operation based on that. So what is the complexity of this, right? I know that I have some while loops here and some while loops here and a for loop here, but it is going to be O of n in linear time, and you need to because n is 10 to the 5th. This is linear time because for every element, you only push and pop a couple of times. You push or pop on this stack once, and you push and pop on this stack once. So you're only doing a constant number of pushing and popping per element. So that is going to be linear time. And for space, it's linear space because we have 2 stacks. Again, you don't really need it the way that I did it, but yeah, that's all I have for this one. Yeah, that's all I have for this one. Let me know what you think. You could watch me kind of solve this live next, but I think I actually spent about 40 minutes on the original problem, and then I spent about 20 minutes making it work for this problem. So if you want to say I probably took an hour on this one, so I would not have been able to solve this only because I spent too long on Q3. But I mean, I had the idea for this one, but even during the original contest, but I think it's just very easy to get this wrong, as you can kind of see. But yeah, that's all I have. If you like it, please hit the like button or subscribe button or whatever you need to do. I will see you later. You can watch me solve it live or hack this live next in 2 minutes. Okay, let's see if I could get this real quick. Oh my, what? I wrote a tutorial on this, so. Oh, in binary search, I think. Maybe I wrote it. I don't know. So yeah. Answer is dynamic programming. Man, binary search changed the way that they did stuff. No, just give me my what? Give me my editorials. So I would have gotten this really quickly actually, but assuming it's the same problem. But I cannot get this one, so I mean, I think I did it pretty okay during the contest too, but okay, so this is wrong. Maybe this is not the same statement. What are we doing? Maybe I misunderstood this one. No, I mean, why is this 3? Did they change the cost function? Why is this not 2? It is 2 on the binary search. I don't even know. I can't get anything right today, even when I have to answer. Why is this 3? Maybe I have a typo. This gets AC on binary search. Maybe the binary search solution that I had is incorrect. But this is going to be impossible to debug. Man, I cannot do anything right today. Okay, so okay, this is a struggle. So this. X2, okay. It takes 2 to shift here. Huh. Why do I have an extra thingy? What? Okay, so this is mostly right, but it's just not combining in a good way. But why is that? Like, why does it have 2 things? Oh man, I am really bad today. Even copy and pasting code, my old code is wrong, but I don't get it. Oh, I see. The reason why my code is wrong is because they have a thing where they don't parenthesize everything. Okay. So that's what's different about this one. They changed it just a little bit annoying enough. Okay, how do I fix it? So in the original solution, they would have something like parenthesize like this. So I think I just had to So if it's 100 and we append this. Okay, how do I debug this? Or how do I make this thing? So on this, we only take 2 operations, but we need to keep doing this until it is the thing, right? Maybe? I hope that's right. Okay, so here we append. So this will mess up, that's fine. Maybe not. Maybe it would have been faster if I just start from scratch. Well, that's fun, but not quite the answer I'm looking for. Oh, sadness. Why? How? How? Okay. Oh, this is wrong. This is. So this it tries to do. Okay, now it is more correct. What's my print statement? Okay. I have another print statement here. That's kind of funny though. That actually my solution was wrong in the other one. I just. Yeah, well. Oh, and it doesn't even have to have operations. Wow. I guess this is a tougher variation than I expected. Well, I think the idea is right. It's just I am not going to get this one probably. Huh. It's kind of funny. Yeah. Could have gone this way quickly if I, yeah, poop. So of all these things, I have to combine them. Wait, but okay, so it does get combined, just not in a good way. Well, I think the reason is because now we have to do it left to right within the parens, but I'm not doing that. I'm doing it from right to left, which probably gives me the wrong answer as a result. This is going to be a mess. Okay, let's do something a little bit funky. Pop them empty list. Okay. Okay, so I think I fixed it. I don't know if it's gonna be fast enough, but at this point I have nothing to lose. Okay.